Welcome to the class. Today we will be seeing class 10 CBSC NCERT unit of first unit of the physics, light reflection and refraction. So what is reflection? Where it happens? So reflection is nothing but if you have a surface and the medium here we are talking in this lesson is your light. If your light is incident on that surface and if it is getting bounced back or reflected back, that phenomena is known as reflection. Alright, so you have a surface and your incident medium is the light. If it gets bounced back from by that surface, it is called reflection. So what is refraction then? Yes, I guess you would have all guessed it correctly. So your incident medium is your light here. If it gets passed through the surface, then that is called as refraction. So when your medium or when your light is getting bounced back, it is called reflection, and when your medium light is getting passed through your surface, then it is called as refraction. So reflection, where would you use that word? Yes, in your mirrors, the mirrors you see in your day-to-day life, you say, see your reflection like that, and the metal surfaces, your shiny metal surfaces like your, spoon, utensils, all the metal surfaces, you could observe reflection. Metals particularly which are shine. Alright, where would you see the refraction? Uh, in your transparent mediums, only in your transparent surfaces, the light can pass through it. For example, the lens. Imagine the lens of your specs, yes, or any plastic, no, light plastic surfaces where you could see through it. You know, those are good examples of your refraction. When we talk about reflection, and we have discussed that it happens in mirrors. So we have to, classify the mirrors. There are plain mirrors, the mirrors which you use in your day-to-day life, in your wardrobes and all. Those are plain mirrors. And also there are concave and convex mirrors. Okay, so what is concave and convex? So I'll be teaching you a simple trick which my teacher taught me in my smaller classes to easily remember your concave and convex. So draw a sphere like this and split it into half at the center. The one at the left side is known as convex. The one at the right side is called as concave. In other words, as the name suggests, concave is just like a cave. No? Imagine the cave of animals, how will it be? It will be hollow inside for the animals to enter in. So same it is in your concave mirrors. So it is hollow, hollow inside. Yes, concave is like the cave of your animals. So how is convex? It is bulging outwards. Alright, this is convex mirrors. So now we can actually discuss the examples of concave and convex mirrors. So where are concave mirrors used? Or say, let me give you a simple example of the concave mirror. Is your spoon. Just remember your spoon. Take a spoon and look at yourself in the spoon. The inside portion of the spoon. The place where you eat with the spoon, the hollow portion, that is just like your concave part, right? This is the spoon. This part which is hollow is just like your concave. The one which is outward, the back side of your spoon, is your convex. So now you hold your concave part of the spoon and see yourself at a distance. How will you be? You will appear inverted. Right? You will appear inverted on the concave part of your spoon. Whereas in your convex, how will you appear? You will appear erect. Now, bring the concave part, near by you, or just instead of seeing your face, you just hold your finger on the concave part of your spoon at a distance. Suppose this is your finger. Until a particular distance, your finger will appear inverted. As you get nearer to your spoon, your finger will be erect and magnified. Yes, that is the speciality of your concave mirror. Until a particular distance, your image will be inverted. And when the object is nearing your concave mirror, it will be erect and magnified. Whereas in a convex part, always, if you hold your finger at the back side of the spoon, it will be always erect. With this note, let us talk talk about the technical points of both your concave and convex mirrors. So in your both concave and convex mirrors, there are some parts. No. So again, let me draw a circle and make it easy for you to remember. So if this is the radius of the circle, no, this is the center O, and this is the radius of the circle. Let me name it as C. Draw a line. Draw a line passing through the center of the circle. Mean your diameter. Alright. So this is the center. At equal distance, if suppose the total distance you have drawn the circle to be 6 centimeter. No, this is the radius. Okay. I'm talking about this circle. I mean an example. At the midway, from the C at 3 centimeter, you draw a point F, focus. And from the focus at 3 centimeter, you draw a point P, known as pole. Likewise, repeat it on the left hand side. At 3 centimeter, you draw a focal point F, and again at 3 centimeter from your focal point you have to draw a point P2. Now again dividing the circle into half. This is your what is it? Concave or convex? Yes, very good. Convex, and this is your concave. Now these all the measurements 6, 3 and all, I'm just giving it for the example for you to understand, right? So this is C, center of curvature. So concave mirror has the center of curvature. Center of curvature is nothing but the radius of the circle. Radius of the whole circle we have drawn here. C is the center of curvature. C is center of curvature. And F1, F is nothing but focal point. P is the pole. So if I redraw the circle for the concave and convex separately, convex mirror has a pole, F focal point, and a center of curvature. For concave, yes, you have all the three. This is your pole, this is your focal point, this is the center of curvature. In other words, you can tell pole is nothing but the surface where your light hits the mirror. Always the pole is at the surface of your mirror. See here, both in concave, convex and also in concave, the pole is near to the surface of the mirror. Focus is at a point center to both center of curvature and P in both concave and convex. Or in other words, you could tell that if C was the radius of the circle connecting both concave and convex, F lies equidistant and midway. I would say equidistant and midway from the pole. Or in other words, you could simply tell the distance CF is equal to PF, which is nothing but both are the radius of the circle. Or in other words, you could say that CP is equal to 2R. Yes. Or F is equal to R by 2. I hope you understood this. is equal to 2f. So what is the point here? From the center of curvature is nothing but the radius of the circle, and at the equidistant on both the sides lie your f, or in the midway. If suppose 6 is the radius of the circle, at 3 centimeters at both the sides lie your focal points. And with the same distance from F lies your P. If this is 3 centimeter, then F to P is also 3 centimeter. This is example which I am telling you. So CF is equal to PF. Both are nothing but radius. So CP is nothing but CP is nothing but, I'm sorry, CP is nothing but your R. CP is nothing but R, and F is 2R, R by 2. F is R by 2. I'm sorry for the confusion here. CP is the radius of the circle, and F is lying in between or at the midway of the radius. So it is at the distance R by 2. R by 2. And R is nothing but 2F from this equation.